Today, we're going to pull back the curtain on the powerful, incredibly precise, and, believe it or not, surprisingly versatile world of energetic materials.
Okay, let's just jump right in with a number, 8.91 kilometers per second. To put that in perspective, that's over 19,000 miles per hour. That is fast enough to zip around the entire planet in just a little over 2 hours. So, what on Earth is moving that fast?
Well, it's not a what, it's a how fast. This is called detonation velocity. And that absolutely mind-boggling speed, it belongs to a brand new generation of high-performance energetic material. So today, we're exploring the hidden science behind these substances, from making them way more powerful to detecting them with some seriously futuristic tech. So first up, let's talk about the relentless pursuit of more power. Scientists are always looking for ways to improve the performance of energetic materials, and they've just hit a major breakthrough. See, for a long time, the gold standard was a formulation called HMX-based OWC. But now, researchers have developed something totally new, a co-crystal formulation called PHX-153. Now, a co-crystal is basically a material made from 2 or more different molecules, all arranged in this super-ordered repeating pattern. And it's that unique structure that completely changes the game. So how much of a game changer are we talking about? Well, compared to the old HMX standard, PHX-153 gives you a 3.6% boost in detonation velocity and, get this, a 6.4% jump in detonation pressure. Now, I know those might sound like small percentages, but in the world of high explosives, they are not. This is a huge leap forward. And here's the really cool part. This isn't just about a bigger bang, it's about smarter power. Turns out, the same molecular structure that makes PHX-153 more powerful also makes it less sensitive to things like accidental friction and impact. What does that mean? It means it's not only more effective, but it's actually safer to make and to handle.
But more power isn't always the answer. Sometimes, the real innovation is having a little bit less. So let's look at how the search for less power is actually leading to way more precision and control.
Think about fields like mining or construction. You don't want to just cause maximum destruction, right? You want surgical precision. By engineering explosives with a lower detonation velocity, engineers can control exactly how rock fractures, breaking only what they need to without damaging everything around it. It's really about finesse, not just brute force.
And this whole need for control and understanding leads to some pretty interesting situations. Take a material called G-dam dust. For a while there, depending on who you asked, it was either a serious explosive risk or it was just totally harmless dust. So, what was the real story?
Well, the answer turned out to be all about context. Yes, G-dam dust can be explosive, but only under very specific lab conditions. We're talking high temperatures, high pressures, all in a tiny contained space. But out here in the real world, under normal conditions, it's harmless. And that just highlights a super important point. The environment a material is in can be just as important as the material itself.
Okay, so we've talked about making materials more powerful and also more precise. But what if we could just flip this entire science on its head? What if we used it not to create a bang, but to find one that's already out there? This is where our story takes a really fascinating turn.
I mean, seriously, this sounds like something straight out of a spy movie, doesn't it? Just imagine an investigator showing up to a crime scene, pulling out a device, and 3D printing a custom sensor right there on the spot to scan for hidden traces of explosives. Well, that science fiction is quickly becoming science fact. And the process is actually incredibly simple. Scientists have developed these special conductive filaments for 3D printers. So you just print the sensor, which has this rough, porous surface that's perfect for grabbing particles. Then you rub it on a suspicious area, and an electrochemical analysis can detect the chemical signature of TNT. It's basically a crime lab in the palm of your hand. And this kind of forensic material science just keeps getting crazier. In another study, researchers figured out how to analyze the unique mix of ions on banknotes. They found that money seized from an ATM robbery had a distinct ionic fingerprint, which let them easily tell it apart from regular cash. Just incredible.
So this whole science of engineering materials for extreme performance, it's not just for defense and forensics. It's having a truly, explosive impact across tons of other industries, and often in ways you would never, ever expect.
Let me give you a perfect example. The big innovation here isn't some new explosive compound. It's a revolutionary new surface coating made by bonding graphene directly to aluminum.
So what does this simple coating do? Well, it boosts thermal stability, It doubles the aluminum's resistance to corrosion, and it makes the surface absorb 3 times more light. And what does that mean in the real world? Think way more durable, more efficient solar panels and thermal collectors. And the best part? The process is totally scalable for industrial use, right now.
So, from more powerful weapons to more efficient clean energy, this is all part of a huge revolution in how we design and build the world around us. So let's take a quick peek at what's coming next.
I mean, just look at what's on the horizon. We've got these things called silicon carbide whiskers that are being used to build better high-power electronic devices. We've got graphene oxide films that are paving the way for new kinds of LEDs and light sensors. And new materials like NETRGO are making ultra-high-density energy storage possible. We're talking about the next generation of batteries and supercapacitors.
So, what's the one thing that connects all of these incredible innovations? It's our rapidly growing ability to engineer materials at the most fundamental atomic level. By designing and arranging molecules exactly how we want them, we are unlocking capabilities that were pure science fiction just a decade ago. Which really leaves us with one last big question. The very same field of science is giving us more powerful explosives and more precise mining tools, incredible forensic sensors, and better solar panels. As we get better and better at designing our world atom by atom, it really makes you stop and think, what kind of future are we choosing to build with all this amazing new power?